off by going back over the year 11 working, like leading into year 12. We've been looking at concurrent forces and how they actually react, and then started looking at moments as well, which is another part of the year 11 course. But we're now starting to expand those ideas into the HSC course. So you will get a question like this in the HSC exam. So the example that I've actually provided here for you is obviously of a beam bridge where we have a pin and we have a roller. Okay, now what we need to do in this case here, we need to actually calculate the moments around the pin. Okay, so we've got all of these forces coming down this way, so we're assuming that the moments are going to be positive, travelling in this direction. Okay, it's going to be spinning around the pin that way to counteract these forces down. So while these forces are here and they're spinning that way, this counter force is going to be pushing up, which means it's spinning around this way. Now, before we go any further, let's have a look at the nodes that we've actually got. Like, we've got the distances, which is fantastic, and we've got the forces. However, we've got some issues here with this force and with this force. We can't calculate them on the angle. So what we actually need to do here is change these into the horizontal and the vertical force. Okay, same with this one here. We need to get the horizontal and we also need to get the vertical force here to be able to do all the calculations. Okay, once we have the vertical forces, we can calculate the moments, and then with the horizontal forces, we can actually then calculate those forces by using the sum of all forces. Okay. Remembering, the pin reaction will have a vertical force and it will be resisting a horizontal force. Okay, so at this end here, we'll have both vertical and horizontal. Because this is a roller and the bridge can move this way, that means that it does not actually have a horizontal force. It does have one vertically because it's holding the bridge up, okay, which we need to take into account. So the first way that I go about this is to transfer our space diagram into a free body. You can see here I've used red to help me understand what I need to know. I need to know this horizontal force here at the pin, this vertical one. RL stands for reaction left. RR is reaction vertical. So we've got a horizontal and a vertical on the left and a vertical on the right. Now again, like I said, we need to change this force at 55 kilonewtons and this one at 50. So in red, I've actually drawn my 90-degree triangles, and that's the first thing that I'm actually going to do. Here, this NTS just means not to scale, okay? I haven't done anything to scale, so I've just left it like that. Small chunks is the best way to go with this. You can see here, first thing I've done, I've got my XY. All right, Sokotoa, again, look, I know you guys have got shortcuts. Please remember though, you need to show working in the HSC to get marks, okay? You might not need to show all of this working, but at least display the formula so that they know what you're talking about. You may not need to do this, right? You should do this, you should do this, and you should do this. Like I said, I'm old school. I do this every time so I can remember and try to get it right. Okay, so 55 kilonewtons converted to an XY, and then the 50 down here the same way, converted to an XY, so that we actually now know with our free body diagram what all the forces are. Again, I'm drawing in this so I can actually understand what I'm doing. I've converted my original forces that were here to my X, like vertical and horizontals, so I can understand it. Again, this is me. If you feel that you can actually cut that corner, cool, you go for it. But you need to show the working. Okay, so now this is the first thing we need to do is take the moments around RL to be able to know what the reaction, the vertical reaction here at right is. So again, when we're looking at this, for equilibrium, because we know the bridge is in equilibrium, the sum of all moments, and I've put in the direction that I'm taking the moments, right? And I'm saying that that's positive, equals 0. Therefore, 0 equals, right, 42.13. You can actually see it's coming down, right? The force is coming down. So if this was actually spinning, this force is trying to make it spin this way. Okay, so it is negative because I've said I want the positives going the other way. So I've got negative 42.13 by 4. Again, this force is negative. Oh, I left out the 20 there. It's 20 by 8. So there's 4, which is 8, 20 by 8. The next one here, 43.3. And it's 1, 2, 3. 3 by 4 is 12. So I've got 12 there. And the final one is the reaction vertical. And you can see here it is 16 metres away from the pin joint. Pretty much a straight calculation there. The only thing is that as I'm going through, the negatives cancel out to get my answer there. So I know it's positive, which I know that my sense was correct. This is a vertical going up. Okay. To find the, over here, the reaction here is vertical going up. Okay, to find my left-hand side one, it's for equilibrium, the sum of all forces must equal 0. Okay, so in this case here, I'm trying to find the left-hand reaction. Again, this force is coming down, so it's a negative, negative, negative. This one's going up, so it's a positive to get my end result. Now here I've also got my horizontal forces, right? So to find this, again, it's the sum of all forces. Okay, so we have 35.5 going in this direction, so that's a negative. This is a positive, and I'm guessing that this one's a positive as well. And you can see by the numbers it is. So working through the equation, here we go, minus 35.5, 25, that gives us 10.35, okay? Now, the question, I'm just going to come back up here because this is what you need to understand with the question. It says determine the reactions at both A and B, right? So the reactions, it wants the resultant force at both A and B. Here at B, because it's on the roller, we're only going to have this as vertical. Because we've got a horizontal and a vertical force here, it means that the reaction is actually going to be pushing on an angle. It's going to be pushing on an angle, and that's what they want to know. What is the magnitude of that force and what is the angle of that force at A? So if you only leave it as coming down here, let me just do this. If you only leave it at 10.35 and 52.43, you can't get full marks because you haven't actually gotten the resultant force. Here again, as we work in concurrent forces, look, I've drawn my force triangle again so I can understand. I'm coming out 10.35 and I'm going up 52.43, and now I've got myself a right angle triangle where I can calculate oh, look at that, that's wrong there, isn't it? That's interesting. Anyway, so did I do that right? See, I've got this wrong. I've got to change that one. Okay, so you can see, and again, I'll come to checking in a second because that's really important. So you can see here, I've got the sense of this actually wrong, right? So I'm coming out 10.35, going up that way, so the force is actually going in that direction. My calculations will be correct for the angle, but I would have lost marks for this. Okay, I would have lost marks for that, and I'm going to actually change that now, right? And again, I've gotten that wrong. That's okay to get that wrong here because I'm actually still stating it, but down here, it's a biggie, a big mistake. Coming to that idea of checking, you can see I didn't check. I just lost 1 mark because of that. If this is a 4-mark question, which it probably is in the HSC, probably would have gotten 3 because of that little thing there. I want to make sure, to get 4 marks, you want to show the working and show the working out. But here again, I've got that wrong. Now, I just wanted to show you, like it happens to all of us. Have a look at this, right? I want you, like, if you have a look at this, if I didn't check early on, my whole question would have been stuffed. Okay, so it's really important that you not only get the knowns and unknowns, but when you actually work the solution, you have to check it. Here, stupid rookie mistake. I put the horizontal here on the roller. It should have been over this side. That's the first one. Again here, and this is a big mistake we all make, I've gone 4, 8, 12, but on the last one, I put in 4 instead of 16. So I totally blew everything out. It's really, really, really important that you actually do cast your eye over this and check to make sure that you get it right. Okay? So, excuse me, that's bending moments. That's moments and force diagrams. And we're going to use this same example for the future, where we're going to look at now, or next I should say, shear force diagrams and bending moments based on the results here.